Hi, I'm Herbert Wolverson with Libra QoS. Thanks for having me at ZANOG 2025. I'm part of the Libra QoS team. Every ISP needs to use a QoE middle box on their network. Be joined for questions at the end by Robert Chacon and Frank Bortzik. We look forward to talking to you. Sorry this is recorded, but it's a long way for us to fly. So LibreQoS is on a mission to save the internet. Robert Chacon started out by saying, I must fix this. He built LibreQoS to apply FQCodel and then Cake to customer connections. During the COVID pandemic, it was kind of an emergency for every ISP, pretty much every ISP worldwide. All of a sudden, all your residential customers are now business customers at home. They expect their Zoom calls to the office to be perfect. They expect all the downloads that they normally do during well-managed peak time in the evenings to work all day long. And even worse, they expect both to work at once. Robert set out with the mission to fix that first for his ISP in El Paso, Texas, and then second to release that as open source and start offering the same level of protection and improvement to quality of experience to the world. So Robert started the ball rolling. I must fix this. Now Dave Täht came along. He had been working 14 years to try and produce better internet latency, feasible. Why wasn't it fully deployed yet? He was one of the brains behind Cake and FQCodel and Codel before that, and all he really wanted was to make the internet a better place. LibreQoS' mission aligned perfectly with his, so he came on board. And then Herbert Wolverson, that's me, Chief Product Officer. My ISP needs this, I'll rewrite it in Rust. So my ISP in Central Missouri was suffering. LibreQoS made it work again. The pandemic, and particularly just the shift towards video conferencing in general, made latency really critical to happy operations and happy customers. We'd previously used a few other QoE solutions, weren't entirely happy with them. I knew about Cake, I knew about FQCodel, and when I saw what Robert had produced, I really wanted to jump in and start helping. So I rolled up my sleeves, rewrote a large chunk of it in Rust, to make it align with what my ISP needs, and I teach Rust professionally, so it was a natural choice. I'm not one of those guys who yells, rewrite it in Rust from the corner, I promise. So I started adding features, things started coming together, we started to have something that looked a lot more like a useful tool that people could understand rather than a lot of scary command line stuff. So František Bortzik, or Frank as we call him, came along. He insists on the job title Gopher. In reality, Frank runs an awesome community, keeps us on track, and really has a knack for connecting with all the people we talk to. That's Frank's job. He says Gopher, I would say absolutely essential staff member. But Frank's big thing was the internet needs this. He's looking at what we're doing, looking at the improvements we're seeing, really wants to get it out there, and particularly get it out there to developing markets that need it the most. And so, with Frank on board, we forged ahead with tackling the problems. First one is the bufferbloat problem. This was always Dave's pet project. Bufferbloat is simply when you have too much data trying to go through too small a pipe. As a result, you make a bigger and bigger buffer, and your buffer starts becoming the problem. Bufferbloat, it does sound uncomfortable, and it's definitely uncomfortable when you have it. Have your customers ever called you complaining of slow speeds? You look, their net connection's just fine, but someone's decided that it's time to download Call of Duty. Someone else in the house has decided that it's time to have an important Zoom meeting. The Zoom meeting keeps flashing up the error messages, warning that the connection is unstable. You look bad, your customer's unhappy, grumpy customers. Have you ever experienced a jittery voice-over IP phone call or video conferencing session while everything looks to be fine on the hardware level? Have you ever rage quit a video game because, and maybe even threatened to quit your ISP because you died because of lag? Well, honestly, that's usually a skill issue, but most of the time, lag can be helped in real-time games, even if your daughter decides that it's time to download the entirety of Peppa Pig. Now, the reason for this is that most routers enqueue packets in a linear fashion. Packets come in, work their way up the queue, packets bounce out. When the queue is full, packets bounce off the tail or dropped indiscriminately, and no effort is made to balance the flows, that is, traffic between different endpoints. Many routers have huge buffers. Some hardware manufacturers have even boasted that they have the biggest buffers in the industry. And time in buffer can become a latency problem by itself. So CODL, the first protocol that Dave and others worked on, started out adding time in transit to packets in a router, dropping old packets, and thereby optimizing the amount of time that is spent waiting in the buffer. Not perfect, but a great start. FQCODL added a better timing algorithm and starts tracking timing per flow. Fair queuing. So now when you have multiple flows, that is, differentiated flows between different points on the internet, FQCODL is tracking them individually, prioritizing the small, well-behaved ones, which would happen to be your Zoom call, your gaming, and deprioritizing the really big, bloated ones, which would happen to be your daughter deciding that Peppa Pig is necessary during your meeting, or Call of Duty update. And now your voice over IP and video traffic works pretty well when your pipe is full. FQCODL is excellent. Cake is basically FQCODL on steroids, with a better timing algorithm, traffic divided up into tins by traffic type, without needing to do intrusive deep packet inspection. Best of all, it's 100% open source, and it's included in the Linux kernel. So buffer bloat is most evident when the connection is heavily loaded, but it can cause increased latency or ping or problems or lag in online gaming, even when your connection is somewhat idle if upstream buffers are just poorly optimized. Most of the time, though, this helps you maintain great performance, even though you have a fully working connection. It just makes sure that everything works by rearranging the packets. So flow queuing is almost enough today. 98% of flows don't need active queue management, but the 2% that do need it desperately. Otherwise, the principal driver of subscriber bandwidth is video streaming. To get 4K video, provision about 35 megabits to the user, with the -410 rule. Per customer average at peak time is no more than 6 to 10 megabits, even if you give them a gigabit in most cases. That number is slowly ticking upwards, but regular consumer use, when averaged, is still pretty low. Gaming, DNS, keystrokes, voice over IP, video conferencing must always just work. And the reason for that is, even though it's not really your fault, you, the provider, you know that your customers are going to call you at 2 in the morning to tell you all about the problem that they just experienced. So Libra QoS, buffer bloat, and active queuing is all about reducing the number of times they call you at inconvenient moments. Ideally, nobody really starts to care about lag anymore, except on Wi-Fi, where sometimes your Wi-Fi connection is just plain bad. That's a topic for another day. Looking at the little spinning graphic there, you've got the benefit of cake being illustrated. The top flow, as you can see, is a lot of packets, very full. The bottom flow, just a couple of packets. Flow at the very bottom, just a couple of packets. Even fair queuing will help here by taking packets one at a time. Target B and target C, the voice and the video, will remain smooth because they're not waiting in line behind the big bulk. Cake will start to actively implement a priority queue and make sure that the video, because interactive video is the most subject to jitter, and the voice, which is also subject to jitter but gives you a little more tolerance, remain absolutely silky smooth, even though target A is completely filling the buffer. Now, in an ideal world, you do this at every level of your network. In practice, that's not always practical. So when buffer bloat started out, the hope was that we could go out, and Dave and Frank in particular could go out and install OpenWRT, OpenWrt, configure CakeSQM on every CPE out there, change every device in the world, everybody's doing great, done. Problem is, it's really kind of hard to get everybody to go out and change all the CPEs at once. That just doesn't work. So the goal of the bufferbloat project has always been to try and get the ISPs to do it right instead. There's been a lot of progress with DOCSIS, Pi, and Alpha-S, but ultimately we believe that everybody should have cake. The problem is, for ISPs, you're shaping inbound on the home router. That's the wrong place. You want to shape it before it gets to your home router so as to not clog your internal connections. It's CPU intensive. You need a bigger router. Router upgrades are expensive. Doing this for thousands of customers at once makes multiple bottlenecks. Libra QoS acts as a middle box instead that you install at your egress point into the internet. All the packets going through it automatically have cake applied. Links to your CRM or other management system, your network gets better. So typical customer response from somebody running Libra QoS, we ask them to run the waveform buffer bloat test, is A+. You typically will see latency you'll always see latency because we can't change the laws of physics. What you don't want to see is that magic download active and upload active raising significantly. When that raises significantly, it's a good indication that there's a buffering problem somewhere between you and the endpoint. Because if your router is actively managing the buffers, then all your flows are running at approximately 1 round trip time, the appropriate speed. If you're not managing your buffers, packets build up, get delivered in bursts, you start to see the nasty spiky connections and active latency under download and upload problems that really ruin everybody's day. So you can get an A+ on this score with a 10 meg connection, you can get an A+ on this score with a gig connection, and vice versa. It's quite possible to get an F on a really poor fiber connection. So what challenges did we face? The first one we tackled was that Linux traffic control is single-threaded, which is fine for normal home users, a real problem when you start to wanting to shape tens or even hundreds of gigabits per second. And so we joined with the XDP CPU map project to find a way to start spreading that load using MQ and still apply cake to individual connections. We've worked closely with the people who wrote that. I've personally submitted a whole bunch of patches upstream, adding things like IPv6 support. It works beautifully, provides a great core, and now with the right setup, you can achieve latency spread across all of your cores, 64 cores even. And we've been seeing customers pushing 80, 90, 100 gigabits per second on the right hardware. Also scales down really nicely. You don't need a very big box to start pushing 10 or even 1 gigabit per second. So LibreQoS is set up as a hierarchy. This matches the HTB hierarchy that's inside Linux. HTB is hierarchical token bucket. Basically, you map every level on the network to a bucket, and that bucket can share tokens. So for example, at the root of the network, we have flows here that are represented in capacity by the width, and they start to turn red when they're full. And the bar color is indicating if we're detecting some round-trip time latency. We're monitoring all of this in real time, although this is obviously a frozen graphic. But we have one queue at the top, multiple queues for each of the sites working its way down. We're modeling the whole topology of the network. And so because we know where the bottlenecks are, we're able to smartly allocate resources to shape the parts of the network that need it. And very rarely do you see a situation in which part of the network is red, it's out of bandwidth, round-trip time on either side firmly in the green, looking great, we're not detecting huge amounts of TCP retransmits. That's exactly where you want to be. If the people down at this node here were to fire up a Zoom call, it would just work, even though they're using all of their capacity at this point. So LibreQoS is a recipe for operational success. Before version 1.4, we could use cake to fight bufferbloat and improve latency, use HTB to model the networks, use XDP CPU map to scale to large networks, drop in a bump-in-the-wire transparent bridge to do this without having to go out to your customers. We could integrate with large numbers of customer relation management solutions to gather traffic plans and apply them in real time. Our experience was that when we turned it on, after a little bit of tuning, we saw a drop of 80% in customer support calls. Talking to our customers, that is actually a pretty typical experience. But now we've slapped a GUI on it, made it much easier to work with. So with our tactical views on LibreQoS, you can see where the hotspots on your network are in real time, find the pain points. You can drill down, identify trouble that is occurring right now. You can receive a call, jump to a customer circuit, watch their experience right now, provide personalized troubleshooting. You can even capture the data for later analysis with other tools. And most of all, we encourage people to submit data to help the people working on bufferbloat to make this even better. This is an example of a real-time flow analysis. So we've zoomed down to one customer whose name is obviously redacted because I don't have any customers who really want all their details shared on public internet. The maximum speed on the plan, 230 by 34. Minimum speed, you can set a commit rate, that is a rate that it will strive to achieve, and then a maximum rate, which is if there is stuff left over. it'll do it. In real time, we're watching them make HTTP and quick requests, the bulk of the bandwidth, to Facebook, of course, Microsoft, Akamai, common sources of network. And we analyze all of this data, collate it, and so you can see, both in real time and over the last few minutes, which ASNs are giving me trouble, which ones are not performing well. Do I need to make some improvements to my infrastructure? Customer calls you, tells you they run a speed test. You don't have to trust them anymore. You can see in real time it appear on the active flows display. Yes, they're doing it, and you usually know the answer before they finish telling you. We track TCP retransmits. These are a wonderful indicator of when things are going wrong. You expect some retransmits at all the time. Cake itself will be dropping packets, causing TCP retransmits. They're not necessarily a bad time. They often, though, serve as early warning. Here is one of Robert's circuits that started to experience physical connection problems. You can see retransmits went through the roof. Even though looking at packet numbers and throughput, it wasn't that bad. But this allows you to see immediately, hey, we've got a problem. It turns out in this case, there was a packet sniffer that had been left turned on, was causing massive packet loss because it was saturating the CPU. These things happen. I wish I could say that even with the best operational rules in the world, they don't, but they do. Life happens. We provide a nice view where you can view your current connections in real time to the whole world. Little green blobs indicate nice, happy connections. Blobs turn orange or even red to indicate that you've got a problem. For example, we were having packet loss to servers in Venezuela. We're in Missouri. The US-Venezuela relationship is a little complicated, so we decided not to probe too deeply there, but we had the tools to do so if we needed to. So LibreQoS's FQ and packet shaping completely remove excessive latency from your network. Really, if you don't believe us, let us know. We'll schedule a demo, or you can just set it up. It's free, open source, no cost. Once your network is LibreQoS optimized, our extensive passive statistics can track the new problems and old inside your network, so sometimes you'll install it, you'll start to wonder what you're doing without it, and then you'll curse it because you found a whole bunch of things to fix. But that's good in the long term because it helps you move towards a smooth, stable experience for your customers. Tracking per ASN performance, if you're connected to an internet exchange, for example, sharing this data with your IX can be extremely helpful to them to figure out what's going wrong. Our latest version integrates with WISP gates, Belinks, Sonar, ISP, PowerCode, Gaia, and VISP. We now support exporting NetFlow data. We pass through ISIS, or ISIS as I keep calling it. Much better web UI, massively improved performance, per flow tracking. We've got it working up to 100 gigabits per second, all the way down to 1 gigabit per second. LibreQoS gives you all this information over the last few minutes. Insight, the only paid component of LibreQoS, can provide this information over longer time periods, whether you want local hosting coming soon, or the cloud version, which is also coming sooner, gives you long-term visibility into your network, and depending on the options you pick, API options to pull some of this data into what you are using. So LibreQoS, our solution leveraging Rust, C, Python, eBPF, and Cake, is now being used by over 500 ISPs around the world, with an average of 30,000 subscribers per box. We're in 28 US states and approximately 50 or more countries. We're spreading all over the world. We've been particularly successful in the developing world, where typically they need the most help. LibreQoS is free, open source software. We love giving it away. We love helping people who need it. Making the internet better for everyone just feels right. So we've helped many parts of the world that need it the most, but unfortunately, Robert, Frank, and I still have to eat. So we recommend a few other test tools of the trade: Flint, iPerf, Crusader, network quality from Apple. All these metrics have bufferbloat now. The bufferbloat crusade has been fantastic in getting the word out about the existence of the problem. I also want to say thank you to NLNet, who funded the development of many of these features. The hosting provider Equinix provided us with test servers and network infrastructure, allowing us to test some of the bigger circuits without having the budget to buy the hardware ourselves. It's amazing. It's awesome. But like I said, we still have to eat. So we've made sure that you can benefit 100% from all of the real-time features of Libra QoS. We almost feel a little sorry about it, but we do charge for insight to help us put bread on the table and also to cover our hosting fees if you're using it cloud rather than locally hosted. So we'll let you know how that goes. Lastly, a case study with CTN Malawi. Frank actually went down to visit Brian Longway in Malawi and talk about his use of Libra QoS. He's been an enthusiastic user for a long time. Regularly tells us that if Libra QoS isn't working for part of his network or something, he knows about it because that's when the phones start ringing. That is exactly what we want to hear. And also that our software has allowed him to bring inexpensive internet out to the places that need it the most. And that is just a good feeling. Frank came back from Malawi just gushing about how good it was that we were able to help, and we want to help more. So if you have a similar situation, please let us know. We would love to work with you, find a way that we can get Libra QoS leveraged in your setup to help you, because that's what we love to do. And unfortunately, Dave Täht, I've mentioned him quite a lot, passed away at the beginning of April. Dave was co-creator of FQ Cake, and he was a leading voice in the fight against bufferbloat. Contributed to Linux, OpenWRT, and more, and he served as our Libra QoS's chief science officer. You're probably using his code without realizing it. Millions of routers around the world contain Dave's contributions. Starlink benefited from his contributions. OpenWRT, the Linux kernel itself. But above all, Dave was a great man and a great friend. We miss him greatly, and encourage you to visit our in memoriam page and maybe send a message of support. So thank you. If you'd like to contact us, you can go to LibreQoS.io or have a look on our GitHub. Highly recommend Taki's Bufferbloat and Beyond thesis if you want to know more about the inner workings of how bufferbloat works. Postscript, what can I do about bufferbloat? Go to bufferbloatandbeyond.net. The Taurus Omnia and GL iNet both flash wonderfully to OpenWRT, give you modern high performance, great performance. You can run Cake on it. That way, if you're just a home user, you don't need to run Libra QoS, a giant server application in your garage. Run an optimized router. RFC 8290 is the RFC that defines FQCuddle and a lot of the code behind this. As Dave would say, bandwidth can be a lie. Lastly, I built most of the Libra QoS interface in Rust. Just want to let you know, if you want to talk to me, I will be at RustConf this autumn, and I'm also the author of Hands on Rust, Advanced Hands on Rust, which is in beta right now, and Rust Brain Teasers. Okay, thank you so much for having me. Now we'll take some questions.